Euclid was never designed to simply capture beautiful photographs of distant galaxies. Its true mission is far more ambitious. Instead of focusing only on the objects that shine, it is searching for the hidden structure that governs the entire universe. At first glance, its images appear peaceful and familiar. Countless galaxies sparkle across the darkness, immense clusters glow in the distance, and deep fields seem filled with nothing but light. Yet the longer those images are examined, the more unsettling they become. The galaxies are not scattered randomly through space. They gather into enormous clusters, stretch along vast filaments, and leave behind immense regions where almost nothing exists. This extraordinary pattern hints at something far greater than the stars themselves. An invisible force is shaping the cosmos, directing the growth of galaxies and controlling the architecture of the universe. That unseen force is dark matter. For decades, scientists have known that dark matter must exist because the visible universe simply does not behave the way gravity predicts. Galaxies rotate too quickly, clusters remain bound together when they should have drifted apart, and light bends around regions where there is far too little visible mass to explain the effect. Until now, much of that evidence came from calculations and indirect observations. Euclid is changing that by revealing the immense framework hidden beneath the visible universe. Its mission is unlike that of most famous space telescopes. Instruments such as Hubble and the James Webb Space Telescope are built to study specific celestial objects in extraordinary detail, uncovering the beauty of galaxies, nebulae, and distant worlds. Euclid has a different purpose. It is creating one of the largest maps of the cosmos ever attempted, allowing scientists to investigate not just where galaxies exist, but why they occupy those positions. This raises an obvious question. How can a telescope observe something that emits no light at all? Dark matter cannot be photographed directly because it neither shines nor reflects light. Instead, Euclid studies its influence. Every massive object bends the fabric of space, causing light from even more distant galaxies to change direction before reaching Earth. This phenomenon, known as gravitational lensing, leaves tiny distortions in the shapes of background galaxies. Those subtle changes act like fingerprints, revealing where invisible matter is hiding. That ability makes Euclid remarkably powerful. It is not simply recording galaxies. It is measuring how those galaxies have been stretched, shifted, and warped by enormous concentrations of unseen mass. By combining millions of these tiny measurements, scientists can reconstruct an invisible map showing where dark matter is distributed across the universe. The results are already astonishing. What first appears to be a collection of isolated galaxies slowly transforms into something much larger. Long cosmic filaments connect distant clusters across unimaginable distances. Massive intersections become the birthplaces of galaxy clusters, while enormous voids separate them like empty oceans. Instead of a random collection of stars and galaxies, the universe begins to resemble a gigantic network held together by invisible gravity. That realization changes the way we think about the cosmos. The glowing galaxies are not the foundation of the universe. They are only its visible surface. Hidden beneath them lies a vast framework of dark matter that existed long before many of those galaxies formed. Ordinary matter gathered inside that invisible scaffolding, eventually creating stars, planets, and everything we can observe today. This is what makes Euclid's first observations so compelling. They are not simply beautiful astronomical photographs. Every faint galaxy serves as a marker. Every slight distortion provides another clue about the invisible structures surrounding it. Each new observation strengthens the growing picture of a universe shaped by forces we still do not completely understand. Scientists have suspected the existence of this hidden framework for generations, but seeing its influence spread across enormous regions of space creates a very different impression. There is an enormous difference between predicting something through mathematics and watching its effects emerge across billions of light years. Euclid is beginning to reveal that invisible architecture with remarkable precision. As more observations arrive, the familiar image of the universe as isolated islands of stars becomes increasingly difficult to defend. Instead, galaxies appear to be lights suspended on an immense cosmic framework. The visible universe may represent only a small fraction of reality, while the vast majority remains invisible, silently directing the evolution of everything around it. That possibility leads to a profound question. If most of the universe is controlled by matter we cannot directly detect, how much of reality have we misunderstood simply because we have spent centuries studying only what shines? The first images from Euclid do not answer that question. They simply make it impossible to ignore. That question becomes even more compelling when Euclid released its first massive sky mosaic. Calling it a single image hardly does it justice. It is an enormous composition built by stitching together hundreds of individual observations, creating a breathtaking view that contains millions of celestial objects spread across an immense region of space. Within this vast panorama are stars from our own Milky Way, countless distant galaxies, enormous galaxy clusters, and faint points of light whose journey began billions of years before Earth even existed. Every tiny speck represents an entire system with its own history, making the sheer scale almost impossible to comprehend. What makes the mosaic even more astonishing is that it represents only a tiny preview of Euclid's ultimate mission. It is not the finished map, nor even a significant fraction of it. It is merely the opening glimpse of a survey that will eventually cover more than 1/3 of the entire sky, creating one of the most detailed three-dimensional maps of the universe ever assembled. Even this early preview stretches the limits of human imagination. Viewed from a distance, enormous cosmic structures emerge across the sky. Zoom in, and individual galaxies suddenly appear with remarkable clarity. Each one may contain hundreds of billions of stars, countless planets, and perhaps even worlds where life has taken shape. Zoom back out once more, and those magnificent galaxies become nothing more than tiny points woven into a pattern so vast that it almost escapes human understanding. That ability to reveal both the largest structures and the smallest details is what sets Euclid apart. Most astronomical images force us to focus on either a close-up object or the broader view of the sky. Euclid bridges those scales, showing how individual galaxies fit into a structure that spans billions of light years. The experience is strangely humbling. Human beings evolved to understand landscapes, oceans, mountains, and planets. We were never meant to visualize billions of galaxies connected across the observable universe by invisible matter. Yet that is exactly what Euclid is revealing. Perhaps the most unsettling aspect of these observations is not simply their size, but their organization. A chaotic universe would almost feel easier to accept. Instead, galaxies trace enormous filaments, gather into dense intersections, and leave behind immense cosmic voids. The pattern appears ordered, not because someone arranged it, but because gravity has shaped matter over billions of years into a remarkably intricate cosmic web.